Hello everyone. In today's class, let us start the discussion about next concept of Newton's laws of motion. Let us see different types of forces here. So actually forces are classified into basically contact and non-contact forces. So based on the physical contact, okay na? So first type contact forces, which one object exerts force on the other with the physical contact. Such forces comes under contact forces here. Next category, non-contact forces, which means one object exerts force on the other one from a large distance or small distance. But actually we don't find any kind of physical contact, even though it can exert force one object on the other one. So we can see one by one. First of all, contact forces which will come under contact forces means basically tension force, next to normal reaction, next to friction. And about this you will learn completely a new lesson actually in the coming parts, okay na? It is actually given as complete lesson, but we will give some introduction for tension and normal force friction, okay na? Let us know one by one first of all. And next non-contact forces. Here under non-contact forces, gravitational force, electrostatic force, next to magnetic force, okay. So these forces will exert one particle on the other particle without physical contact, okay na? Let us start with the contact forces first. So normal reaction and friction, okay. Normal reaction here, whenever object is placed on the ground and it is a point of contact, actually this is point of contact, and for this point of contact it should be act perpendicular, okay na? So now we can take normal reaction upward direction, right? So this counter reaction force actually by the table or ground, always perpendicular component for the water. Here generally we can take from this one, it is a reaction force, one is friction will come, one is what normal come. So the resultant is called contact force here. This is force contact or contact force, and contact force is electrodynamic in nature. So actually friction arises due to electromagnetic interaction between fundamental particles of two bodies. So that's what here it is, its nature electrodynamic they are giving. So one component will come parallel, one component will come perpendicular. That perpendicular force only we can call normal force here, and it is always acts perpendicular to the surface, okay na? So now next here R is equivalent to normal, okay. R perpendicular equal to normal. Actually normal reaction we can call, normal force also we can call, okay. So normal reaction, normal force, reaction force, everything will come as in this manner, okay. Next parallel force. Parallel force means here whenever one person is applying some force on the body to pull it, okay, some dragging force act opposite to motion, right? So that force only called here frictional force. It is actually parallel component for the contact between the surfaces, okay. So this is what actually for how a contact force is divided into normal and friction force, right? Next draw the normal reaction in the following cases. See, normal reaction is always perpendicular to the point of contact. So in this case you can see this is the point of contact. For this it should be a perpendicular. So this is what here it is indicated. So this is right answer. Next here one cylindrical sphere, cylinder or sphere, whatever it is, and at this point one contact we find, at this point we find contact, and for that you can see normal perpendicular, here also normal perpendicular, right? Next in this case here is the contact point we find, and for the contact it is a tangent actually, okay. So for this tangent, that normal forces must be perpendicular. So here you can see this is perpendicular, this is also perpendicular. So this is the way we can draw the normal reactions in different scenarios. Next, tension. So it is also comes under contact force only. When a particular, here it is wall given and it is been fixed with a string and it is pulling left side, right side, okay, he was pulling right side. So this is point of contact, okay. So now this point of contact respect to tension force acts away from this one, and with respect to this point of contact always away from this one, okay, by means of action of thread. Actually the force, here you can see the resistance of a string or a rope against any change in its original composition is called tensile force or tension. Resistance of a string, okay na, or a rope against any change in its original composition is called tensile force, okay. Whatever the change is going to be made in that rope or string, that is opposed by its character or resistance to the change by the rope, it is actually called what? Tension force. Tension is always acts away from the point or tied ends. Next, tension is always pulling in nature, okay na, try to pull like this. And if you can see one more case also, this is a mass suspended with the help of a string. So this is point of contact we find, so upward it is try to pull upward, right, but it won't go because it is balanced. So downward force equal to upward force when acceleration is 0, okay. So this is more about tension actually, right. It is also defined as one more point also, whatever the fundamental particles of the string, okay, will exert attraction or repulsion force on the fundamental particles of the object, and the interaction between them is also results the tension force, okay. This is the way also we can define tension force. Next, different second case, non-contact forces, means they will exert force on each other but very distant, okay na, long away, right. Such a forces are called non-contact. Examples I told you, gravitational force, electrostatic force and magnetic force comes under non-contact forces. Next slide we will see. A non-contact force is a which acts on object without coming physically in contact with it, okay. So here Earth exert gravity on the moon, but actually there is not requirement of physical contact of Earth with the moon, okay. This is gravitational pull towards the Earth itself, that is gravitational force. Next, here it is a horseshoe magnet, it is exerting force on the iron particles or magnetic particles. So this is also no need to make a contact initially, but after pulling it they will attract, but initially they will influence it na? So there is not requirement of any contact. Such forces are called forces at a distance or forces, non-contact forces. So example they have given gravitational, magnetic force and electrostatic force also, okay. So next, weight force, right. If any particle we hold or we just make a throw upward, okay, then it is always pulled downward. Like in the previous example, moon is pulled towards the earth surface, okay. So that force acting towards the earth on the particle is called weight force. Generally F equal to ma, but here particle is accelerated downward with acceleration equal to g. So that's what A equal to g, then F equal to mg. So this force is called weight force or weight of an object. The weight of an object is of mass m near the surface of earth is mg, where g equal to 9.8, because on the surface g equal to 9.8 meter per second square will take. It is always directed towards the center of earth, because every object is being pulled by the earth towards its center only. So that force on every object is called weight force, okay.